All right, so I apologize. I don't know what happened with the video, so I'm going to pick up, I think we can start right here. So the converse of that is that if two angles of a triangle are not congruent, then the longer side is opposite the largest angle. All right, so if I know that angle A is bigger than angle B, I know that the side across from angle A is going to be bigger than the side, or excuse me, if B is bigger than A, the side across from B is bigger than the side across from A. All right, so this picture disappeared somehow, but if we have a triangle of K, M, L, and they tell us that angle M is 62, angle L is 50 degrees. They want to know which side is the longest. So I need to find the largest angle. Well, unfortunately, I only have 2 out of the 3. So step number 1 is to find this angle right here. So I can do that by subtracting these two, and I find that angle K is 68 degrees. So when I'm looking for the longest, I look for the largest angle, and then across from that is the longest side. So across from the K is LM. LM must be the longest side of the triangle. So go ahead and pause the video and attempt the try it here. Again, they left me with 2 out of the 3, so I'm going to solve for the third, just to make sure that I have the largest angle. All right, when I subtract, I find that the final angle is 57 degrees. So what side is the longest? Picking between 65, 57, and 58, I'm going to go with this one. So the side is OP. The shortest is going to be across from this angle O, and that is NP. Pretty simple. Next, we get the triangle inequality theorem. This states that the sum of any two sides of a triangle is greater than the length of the third side. So that means if I have sides A, B, and C, I can add any two and it'll be bigger than the third side. So A plus B has to be bigger than C, B plus C has to be bigger than A plus C has to be bigger than B. So we're going to check these. They give us 3 different side lengths, and we need to figure out if they're going to form a triangle. Sometimes we'll have a triangle with too much left over. Sometimes we don't have enough to fill a side, and this theorem is going to help us figure that out. Now there's a trick to this. So I need to be able to add any two of these sides, and they have to be bigger than the third. So 40 plus 19 has to be bigger than 18. Check. 40 plus 18 has to be bigger than 19. Now the way to get around doing this 3 times is add the 2 smallest ones and make sure that it's bigger than the third. So is 18 plus 19 greater than 40? Well, no, it's not. Okay, so do these make up a triangle? The answer is no. Here, I'm going to check these. Okay, is 66 plus 37 bigger than that? Yes. 66 plus 33 bigger than 37? Yes. The real check is adding, is 33 plus 37 bigger than 66? Is 70 bigger than 66? Yes. So yes, these will form a triangle. Now we need to pay attention to our greater than and less than signs. Notice I don't have an equal to. So if I happen to get a problem and I'm left with 66 is greater than 66, is that true or false? It's false. 66 is not bigger than 66. It's equal to. So it can't be equal to. Now, this is what those of you that attempted the Go Formative were kind of struggling with here. I couldn't figure out. It's not super hard, so I felt bad. You guys were struggling, but you didn't have a video. So A triangle has sides that measure 11 and 16. What are the possible lengths of the third side? So we want to find a range that the third side can be. So I'm going to pretend I have a side 16 or set 11, 16, and then my third side I'm going to use is x. So here's what needs to happen. I know that 11 plus 16 has to be bigger than whatever x is. I also know that 11 plus x has to be bigger than 16, and I know that 16 plus x has to be bigger than 11. Those are the three things that have to be true. Well, these are problems that we can actually solve. I can figure out what x has to be less than. If I add these two together, I find that 27 is greater than x, so x has to be less than 27. If I solve for x here, I subtract 11 on both sides, x has to be greater than 5. So right there, x has to be less than 27, bigger than 5. Now, if I continue going, it's not going to make any sense. I get x is greater than a negative 5. That doesn't help us. A side length cannot be a negative number, so we actually don't have to do this. Right from the get-go, I know that this doesn't make any sense because 16 is already bigger than 11. So you don't need to solve this problem. So what we can do is write a compound inequality stating that the range is between 5 and 27. X is going to be bigger than 5, but less than 27. Go ahead and do the try-its here on your own. So could a triangle have side lengths 16, 39, and 28? Remember, grab the youngest ones, the smallest ones, and ask, is 16 plus 28 greater than 39? Okay, is this going to add up to more than 39? Yes. What do we get? 44? Is 44 bigger than 39? Yes, so I don't need to check the rest. Here, I have 30, 50, x. What is the range? Well, here's the trick. You take these two and add them together. Okay, 30 plus 50 has to be greater than x. So that means x, or 80, is the biggest it can be. Then I know 30 plus x has to be bigger than 50. So I solve. X has to be bigger than 20. So my range is 20 is less than x, which is less than 80. So there is what it has to fall between. Remember, here's the trick. Add them together. That's the biggest number. Subtract the two. That's the smallest number. That's how we'll figure them out. So good luck. I hope that helps much more than the other video.